Good day. Following the lecture on Delft 3D graded sediment simulations that we had before and described how this is implemented in the Delft 3D, in this lecture we want to do some exercises with those type of models and simulations. The main goal of this set of exercises is to set up models with another sediment transport formulation, set up models with more than one fraction of sediment, turn on bookkeeping underlayers in the model, and visuals and compare the results and see the effect of the changes that we have done in the different simulations. In total, we will have two exercises and each with a few components, and we will change different parameters to see the effect of those parameters on the results. It's needless to say that we need to have Delft 3D graphical user interface on our computer. For the first exercise, we want to make a very simple canal which has 100 to 10 cells, and each cell is 100 meter to 50 meter in width. The depth will go from -1 meter till 0 meter, so very mild slope. And the bed level is uniform over width. I need to remind you here that in quick in, -1 meter means 1 meter above the datum, which is 0 in this case. And in downstream, we want to have the boundary condition of 4 meter of water level, and upstream the total discharge of 2000 cubic meter per second. And the rest of this slide shows the other parameters that we want to put in our model setup. Just to show you how the geometry of this simple canal looks like, I have prepared this slide, and you can see the side view on top and the plan view on the bottom. Again, you can see that our canal goes from 1 meter above the datum to 0, which is the datum, and the downstream is 4 meter water level boundary condition, and the upstream is 2000 cubic meter per second water coming into this canal. And this is the dimension of the canal if we look at from the top 10 kilometer to 500 meter. So now let's stop the presentation here and try to build this model in Quick In, and then set up a Delft 3D model and run and see the results. Okay, you can see that I have opened my Delft 3D. Of course, the first thing that I need to do is to select my working directory to make sure that I'm working in the correct working directory. You can also go and choose a directory that you are working in. I have named the directory that I'm working in working directory practically, and I go in. You can see that in the directory that I have, there is another subdirectory called files that can help. If you want to make use of those files that can help you by when we want to copy paste text, you can download that from the eCampus of IHE Delft. But also you can do without that. So I come here and make a directory here, and I call it case 1A, and use that as my working directory in this case. We want to make the first case that I showed you before. So the first thing that I need to make is make the grid. To make the grid, I go to Quicken. I open the Quicken. First, I need to choose my coordinate system. So I choose a Cartesian coordinates, and then I want to make a very simple rectangular grid. I go to Operation, Rectangular Grid, click on it. I remember that I want to have 100 grids in the M direction, and I want to have 10 grid in the N direction. My delta X is 100 meter and my delta Y is 50 meter. So if I click OK, now I see the grid. I have a grid with 10 kilometer in X direction and 500 meter in Y direction. So when I have the grid, the next thing that I need to do is I need to make the depths. So because we want to make a very simple depth, I start by clicking here, choose the depth from up here and clicking here, and then give it -1. Yeah. Again, don't forget that -1 means 1 meter above sea level. You cannot see it here, but as you know, if you go to view and change the depth to colored dots, then it shows up here. Whole length of here, this width of the canal, I want to have 1 meter. So the easiest way is to come to Edit, Depth isoline, choose the first point and choose the last point, and all these points are now -1 meter. The next I need to where I go to my downstream and give the value of what? 0 here. If you remember, we wanted to have 0 value of elevation at our downstream of the canal. So I put 0 here and do the same thing that I did before. Edit, isoline, this till here. So now I have all that I wanted, so -1 to 1. Now I need to interpolate between these 2 points. I can go to Edit, Depth Linear, choose the first point and the last point. And now you can see that automatically it is interpolated between -1 to 0. I can do the same thing for every line, but I may also be able to use the depth line sweep, which is an easier way to copy this line to all the other lines. So I went to Edit, Depth Line Sweep, and I choose the first point here and the last point here. And you can see that it copies the line that I had in all the empty lines above that. So this is practically my depth. And if I want, I can change the view depth to continuous shade to see it better. So this is a now very mild sloping canal. But before leaving Quick In, I need to make sure that I have saved that. I save this by exporting the grid, active grid, as case 1, and I go here and export the depth again as case 1. So now I have this grid and depth, so I don't need the quick in anymore. I close this. I say no because I have already saved this, so I don't need to save it again. I say yes, and then I quit that. Now I need to go to my flow model and start making this model. Just as a reminder, I will go back to the presentation as well to show you a bit of the presentation again. You remember now that we have made the grid and the depth. Now we want to set up the model using these parameters that we have here. So if you don't remember that, just go back and look at this sheet of the exercise. Okay, so we can go now to our flow and we start a flow input to make a new model. For description, just to make sure that I don't forget this, I say case 1A. I write this here. The domain, I have made the grid, so I can open the grid case 1 and then the grid enclosure. Also, I open that from the directory that I have. Then I go to bathymetry. The bathymetry is not uniform. I have already made a depth, so I can open it here. Then I open the case 1 depth as well. I don't have dry points or thin dams at the moment. The time frame that I have, it's now for like 2 days. Yeah, I keep it as 2 days because I want to have the models running quickly to be able to compare the results, but you can play with this if you like. So remember that the hydrodynamic time that we have is 2 days. I go to also the timer step, as was mentioned in the exercise sheet, is 1 minute, so I keep it as 1 minute. In the processes, I want to add sediment because that is what we want to do. For now, I just put one non-cohesive sediment. I add it, and then it says that numerical parameters change to more, which is okay because we want to have morphodynamic model or morphological model anyway. Then I go to initial condition. The initial condition that I want to have is two parameters, water level and sediment. So for the water level, I use what I have given you in the exercise sheet, so 4 meter. And the concentration at the time 0, I keep it 0. So the sediment concentration at time 0, initial condition is 0. It means that the water is a clear water at time 0. There is no sediment uh, in the water column at the beginning of the simulations. Next thing that I should do, I should choose the boundaries. I usually use the visualization to add the boundary. So I go to View, Visualization Area, and I can maximize that as well. So this is the model that we have, and then I can go to Edit Mode, Add, and I want to add open boundaries. So I choose this boundary here, the first boundary, and I choose the second boundary down here. Okay. So if I now close this, both boundaries shows up here. Before I forget what is what, I will call them a better name. So this was my upstream boundary, and this was my downstream boundary. Yeah. So I keep that. In the upstream, if you remember, we wanted to give the total discharge of time series of all four, oh, sorry, 2000 uh, cubic meter per second. So if I click on edit flow condition, I come here and say, okay, all the time it is 2000 cubic meter per second. So close. Now I have it. We can also change our sediment transport condition, but I don't want to do that because I can use the equilibrium condition from the morphological model that it brings automatically the amount of sediment which can be transported by the velocity of at the upstream. So I just keep this as it is, and I will show you later when I can activate that equilibrium concentration. For downstream, if you remember, we wanted to give the water level again time series, and the edit condition we want to have 4 meter of water level constant as boundary condition. Yeah. So I also make all these 4. So I will close this. There's an important thing here that if you remember here, we want to use a reflection alpha of 1,000. If you really want to look at what it means and how it is implemented in the model, you can refer to section 9.4.1.2 of the flow manual of Delft 3D. But in a nutshell, it is to reduce the numerical reflection from the boundary so that the boundary absorbs the energy that goes there. Nothing is reflected unrealistically from the boundary. Then I come back here and put 1,000 here. Yeah. Next, from the boundaries, I need to go to physical parameters. In the physical parameters, this is a physical parameter of practically water and the gravity. I keep them as it is. The roughness we wanted to change. If you remember from the exercise sheet, that was 50. So I will change the chassis of 50. And then the viscosity, we will keep it as is. And in the sediment, we have only one sediment. Yeah. So I will change this as I suggested in the exercise sheet. The reference density, I keep it as it is. The specific density, I keep it as it is. Dry bed density is also okay, but I want to increase the D50 of the sediments to 400. And I will keep this value still 5 meters. So at every point in our canal, we have 5 meter of available sediments in the bed, under the bed of the canal. 5 meter of available sediment. Next, I will go to morphology. First, make sure that this tick is on. So equilibrium, SAM concentration profile, and inflow boundaries is on. If you remember, when we wanted to put the boundary conditions in the upstream, I mentioned that we can put the concentration of the sediment at the upstream to bring sediment with the flow inside the model, which is a realistic condition. We put 0 there, so we didn't change that. But by using this option, we ask the model to calculate the equilibrium concentration that the flow could bring to the model at any time during the simulation and bring that amount of sediment to the model. So it is important to keep this up. The morphological factor, we wanted to change it to 250, again from the exercise sheet. A spin-up interval before morphological changes. So if you notice that when we run the model hydrodynamically, we want to spend some time to get a hydrodynamic stable model before we turn on the morphological changes, but 720 minutes here is too much because it is usually 720 is more for tidal conditions. Because it's a very simple canal and a very uniform flow, I will reduce this to only 1 hour. Yeah. So the rest of the parameters for now, I will keep them as default. So numerical parameters, we keep them as defaults. Operation is not very important because we don't want to add anything to our model as operation. But in the monitoring, it is good to add some observation point and cross sections. To do that, I will go to visualization again, maximize it, and then add some, for example, observation points along the model. So I put 4 observation points from upstream to downstream, and I also add 1 cross section in the middle of the model. Then if we want to have the results, we can do that. Okay, so this is the model that the observation points and discharges that we want to put in the model. Again, you can see that they show up here in the GUI of the model. Then, if we go back and look at the exercise again, we see that we want to change the sediment transport formulation to Engel-Hansen. To do that, we need to add a file to the files of the model and to write specific keywords in that model. That file looks like this. So first, in the additional parameter, we need to use the keyword of TRAFRM, which is transport formulation, and put the name of the text file that we have given the parameters of our new transport formulation. Yeah. And what is in this file, this text file, for the case of Engel and Hansen, is written here. Okay, so we need to copy this in the directory that we work. So the easy or the normal way that we do is that we open a new text file, we write these values inside the text file and save it as, for example, e-h.txt, and then use that name in the additional parameter. But if you have downloaded the directory of files that can help, you can find actually this there. So I will go back to my computer and continue to additional parameter. As I mentioned, I need to add trafrm. Please be careful that you need to observe the capital and small caps. So don't forget that. And I will write the name of the file that I was talking about there. Later, I will show you where is this file. And then in the output, I say, okay, I want to have my map files every like 60 minutes and history every like 5 minutes. And I don't want to have communication file or restart files because those are those makes a lot of files for this simple case that we don't need them. So, and the communication file is when you want to run it with Wave, and I think you may have heard about it already. So now I am ready to save all the files that it is needed, and it automatically the Delft 3D GUI will generate all those files when I click on Save All. So I will say case 1 for all of them. So now it is saving my boundary condition and then saving the other files of boundary condition, saving the cross sections that I wanted, saving the observation points, saving the sediment characteristics, saving the morphological parameters that I put in the model, and save the actual file. It is interesting, you also may get this error that no file name is specified for transport condition. Yeah, it is important that to know that this, when you use the save all, this file is not generated automatically. So you need to go to the boundaries and edit transport. So this is a transport, and then you can save it here. Yeah, transport condition save, and I will call it case 1 again. Save. Close. And now the only thing that I need to do is now save the MDF. So now my model is ready, except that still we have not seen the file of England-Hansen transport formula. If I go to the directory that I had, so working directory, here you can see it. Just for your information, I'm using Total Commander as my browser rather than the Windows browser. So if I look at the files that can help, I already have ehtxt. Let's see what is in this. The text that I showed you on the slide is now copied here. One I4 means that I want to use the first sediment transport in the list of sediment transport formulation of Delft 3D, which is England-Hansen. This one is again the same thing, and these are the two parameters which is needed for this sediment transport. In Delft 3D, you can use many different sediment transport relations, and if you want to see others and what parameters is needed for others, you can refer to manual, or you can also ask me if you have a specific question about a specific sediment transport formulation. But you can see that I have this here, and I will copy this file in my working directory, which was case 1 directory. I will make a copy there. So now I have all the cases that all the files that are necessary to run the simulation. So now I go and quickly run the simulation. I go to start, and then I browse and choose my case 1 MDF, which I just made, and say, okay, let's run this. This model should run very quickly, so it is about 21 seconds to run. So if you have got here and your model is running, most probably whatever you have done is correct. Sometimes also you get errors, and then you can check for the error and then try to fix it. Now that is done, I close this, and then it is important that if you have errors, those you can find the better description of those errors in Delft 3D log file or in the diagnostic file, which is the second file on this list here. So if you go in here, you see whatever model has done is written in these two files, so diagnostic and the log file. And if you find an error somewhere, usually the better description of those errors are written here.